Have you ever wondered what really happens in that first semester of a computer science degree? It's way more than just a bunch of classes. It's about building this essential coder's toolkit, the very foundation that our entire digital world is built on. So let's open it up and see what's inside. Now, really, just stop and think about it for a second. Every single app on your phone, every website, all of it. How does any of this stuff actually work? I mean, it feels like magic, right? But what we're about to see is that it's something way, way more interesting than magic. And that's the secret sauce. This is the core of everything you learn in that first semester. It all boils down to mastering these three pillars. You learn how to think with pure, unshakable logic, how to speak the universal language of mathematics, and how to understand the physical machine that actually brings it all to life.
All right, first up, we're diving into the deep end. We're starting with the most abstract, but honestly the most crucial part, learning the invisible rules that, and I'm not kidding, run absolutely everything in the world of computing. See, before you can even start talking to a computer, you both have to agree on the rules of the game. And that's where propositional logic comes in. It's this beautiful, simple, universal system of true and false that leaves zero room for error. Literally every single complex decision a computer makes is built on top of this simple, powerful foundation. Okay, so we've got our logic. Now we start layering on these super powerful mathematical tools. Think of them like different lenses to see the world. Set theory is all about grouping things, like all your users in New York. Graph theory lets us map out connections, like a social network or the internet itself. And linear algebra, that gives us the power to transform massive chunks of data all at once.
And this is where all that abstract theory suddenly gets super practical. Check this out. Take graph theory. An Euler path is about hitting every single road, which is perfect if you're, say, a snowplow trying to clear a city. But a Hamiltonian path is about visiting every single stop, which is exactly what a UPS driver needs to do. Same basic idea, two totally different, real-world problems. How cool is that?
Okay, so we've got all these abstract rules of the road, but where do they actually live? To figure that out, we have to go from the world of pure ideas to the world of silicon and wires. So it's time to pop the hood and look inside the machine.
You know the device you're watching this on right now? It's the end result of this incredible, long journey. You start with Babbage and his crazy mechanical dreams. You take a giant leap forward with Alan Turing's theoretical machine that defined what was even possible. And then you land on John von Neumann's architecture, the basic blueprint we still use today. It's an amazing story that takes us from gears and levers right to the multi-core processors in our pockets. So, what's actually in a modern computer? Well, the easiest way to think about it is like a human body. The CPU, that's the brain, doing all the heavy lifting. The RAM is its short-term memory, everything it's thinking about right this second. Your hard drive or SSD is the long-term memory, holding all its knowledge. And the motherboard, that's the central nervous system, making sure every single part can talk to every other part instantly.
And this isn't just about reading textbooks. Oh no, you're going to get your hands dirty. One of the first rites of passage is installing an operating system completely from scratch. You're preparing the USB drive, you're talking directly to the machine's deepest level, the BIOS, and you're carving up the hard drive yourself. It's that moment where you go from being a user to being the one in control. All right, so we've got the logic and we understand the machine. Now for the big question, how do we put those two things together to actually do something useful? This is where we learn how to turn pure thought into powerful action.
The answer is you have to learn a whole new way of thinking. It's called computational thinking. And it's this amazing skill where you can take a huge, messy, impossible problem and you learn to break it down into smaller, manageable pieces, find the hidden patterns, and then just ignore all the noise to focus on what really matters. And the whole point of this new way of thinking is to create one thing, an algorithm. Now, don't let that word scare you off. All it is a recipe. A perfectly clear, step-by-step set of instructions that's so simple, even a machine can follow it to do something incredible.
And just like an architect wouldn't build a skyscraper without a blueprint, you don't write code without a plan. That's exactly what a flowchart is for. It's your way of mapping out the logic, the decisions, all the twists and turns of your recipe before you write a single line of code. Get the blueprint right, and the building will stand strong. Okay, so let's recap. We've built our toolkit, right? We have logic, we know the hardware, and we've got a problem-solving strategy. Now for the really fun part, the payoff. This is where we connect all those foundational bits and pieces to the technology that literally shapes our world.
So, remember that graph theory stuff we talked about, with the nodes and the edges? Seemed kind of abstract back then, right?
Well, get this. That exact theory is what powers your GPS. When Google Maps finds you the fastest route to get pizza, it's literally just solving a giant graph problem, the same kind that cracked a famous puzzle from back in the 1700s.
Okay, next up, what about all that linear algebra? The endless rows and columns of numbers in those matrices. What's that good for?
Turns out, that's the secret language of computer graphics. Every single character, every object in a video game, it's just a collection of vectors getting tossed around by matrices. It's also the magic behind secure passwords and even those filters in Photoshop. All right, for our last one, let's bring it full circle. All the way back to the very beginning, remember that simple system of true and false. That first, most basic tool we put in our toolkit? Well, believe it or not, that is the bedrock of artificial intelligence. When you strip it all away, even the most mind-blowing AI is just a massive, massive structure built on those simple rules of true or false to make sense of the world. It's amazing, right? The simplest idea powers the most complex tech we have. So you see, in the end, nothing is random. Nothing is wasted. Every piece of theory, every abstract math concept, every hands-on skill, they all click together. You're not just checking off a list of subjects. You are literally assembling a toolkit that lets you understand, create, and actually build the future.
So, there it is. The tools are in your hands. You've got the logic, you've got the math, you understand the machine. The only question left, and it's the big one that's going to define everything that comes next, is what are you going to build?